Now we're gonna head off away from the planet Venus to check out the next planet from the Sun, the planet Earth. And here we are at the planet Earth. You can see Australia right there. It's actually upside down right now. So I'm going to slowly rotate that right side up. And Earth is the only planet in the universe we know of that supports life. And we can see evidence of that life when we see Earth from space. 2/3 of its surface is covered in liquid water oceans. It's the only place in space where we found liquid water on the surface. And you can see green on its land features. That is the vegetation. And as we get to the backside of the Earth, you can even see the nighttime lights from human activity. And so if you were an alien species staring down at the planet Earth from space, you would immediately know that Earth supports life. Now there's something else that I want to show you. So when we were at the Sun, I talked about how it spews out particles, high energy particles, and some of those reach the planet Earth. If you look close to the North Pole, you can see a ring of green around the North Pole. And this is the Aurora Borealis, also known as the Northern Lights. Now, Earth is protected by a geomagnetic field which surrounds the entire planet, but it meets the Earth at the North and the South Poles. So those areas of our atmosphere are unprotected, and the solar wind interacts with the upper atmosphere at the North and South Pole and causes the atmosphere to glow like this. Now usually it's up near Greenland and Iceland and Norway and Finland and Upper Canada. But if there's a really big solar storm, it can extend further south. If we get a really big storm, we can even see them in Connecticut sometimes. Now, Earth has something that the other inner planets do not have. Earth has a very large moon. So we're going to take a short journey now, about 240,000 miles away, to the moon. Alright, so here we are at the moon. It's about 6 times smaller than Earth, about twice the size of Mercury. And as you can see, it's very rocky, has no atmosphere, and no oceans. And it's covered in craters formed by impacts with asteroids and comets. Now, as we look at the moon from Earth, it doesn't always look exactly the same. It orbits around the Earth about every 27 days, and half of it is illuminated by the sun at any given time. And we can usually only see areas in the sunlight. And so throughout every month, it goes through phases as we see different parts of it. So at the beginning of the month, we see a waxing crescent. It makes a crescent shape, and it's getting bigger and bigger every day as it orbits. 1 week into the month, we reach the first quarter where the whole eastern half is lit up. Then we have a waxing gibbous where it's getting bigger and bigger every day, until halfway through the month we have a full moon, where the entire disk is illuminated. Then the moon starts to shrink into shadow from the east. That's a waning gibbous when it's getting smaller every day. Then when half of it's lit up, that's a third quarter moon. And for the last week of the month in the early morning, we have a waning crescent. And it gets smaller and smaller every day until it gets close to the sun in the sky, and then we have a new moon when the dark side of the moon is facing us. And when it lines up just right with the sun, we might get a solar eclipse during the new moon. Now we're going to watch another orbit of the moon from a different position. Now we're hovering above the Earth and moon in space, watching the orbit of the moon as the Earth spins around. And so even when we see less than half the moon is actually lit up by the sun. And the amount of sunlight we see on the moon depends on the angle we're seeing it from. And if you look at a thin crescent moon in the sky, one of my favorite things to see is something called earthshine. And so here's a picture I took about a month ago. On the eastern limb of the moon, you can see the crescent, which is illuminated by the sun. But we can see the rest of the moon in shadow. So something must be creating light, causing the dark side of the moon to glow. It turns out that is light from the sun reflected off of the Earth, hitting the dark side of the moon and making it glow. Here on Earth, if you ever go outside on a bright moonlit night, you experience moon glow. Well, if you were standing on the dark side of the moon during this moon phase, you would experience Earth glow. Another interesting thing about the moon is its mineral composition. Now, if you look at the moon, it usually looks pretty much black and white. Now, if you take a picture of the moon and enhance its colors, you will see that it actually has differences in color in different areas. And this is due to differences in its mineral composition. All the bluer areas have more titanium, and so those are minerals like ilmenite. And all of the redder and pink areas are areas with less titanium. All the pink areas are a mineral called anorthosite, which has a lot of feldspar in it. And the moon is the furthest place in space that we've ever sent human beings. It's the furthest place we've ever sent astronauts, starting with Apollo 11 with Neil Armstrong and Buzz Aldrin in 1969. And we flew 6 missions to the lunar surface. Only 12 people have walked on the moon, and no one has been there since 1972. Now we're planning a return to the surface of the moon, hopefully in 2024, with the Orion spacecraft and the Space Launch System. So here we are back at the moon, and we're going to take a little closer look at it. Now it just so happens that it rotates on its axis once every 27 days, which is the same amount of time it takes to orbit. It is tidally locked with the Earth. And so as it orbits around Earth, there's one side that always faces Earth, and there's one side that always faces away. It has what's called a near side and a far side. So all of these areas on the moon are areas that you will see on the moon in the sky. But if we go over here, all that you see now is on the far side of the moon. We never see these regions of the moon in the sky, and we didn't know what they looked like until we sent spacecraft around the backside of the moon. And here's one of the largest craters on the entire moon, which happens to be on the far side. And this crater is almost as big as the state of Texas. Now we're just going to fly around the lunar surface for a few minutes and explore it. All of this imagery is from the Lunar Reconnaissance Orbiter, which is currently in orbit around the moon, and it takes very high resolution imagery of the entire surface. Now we're going to go to one of my favorite craters, which is called Plato Crater. Alright, here we are at Plato Crater. This is one of my favorite to see through a telescope. And one very interesting thing about Plato is that it's very flat and smooth at the bottom. It was caused by an enormous impact that was so big it actually went through the entire crust of the moon and filled with lava, which hardened and smoothed out the base of this crater. Another interesting thing about the moon is close to its poles there are some craters in permanent shadow. And so we sent a mission called LCROSS, which actually smashed a rocket stage into a crater on the pole of the moon and watched what came out of it. Then after that, its spacecraft actually smashed into the same crater, and ground-based telescopes watched all the debris come out into the sunlight. And what they learned is that in these craters close to the poles that never see any light is actually water ice, which could be used by astronauts on future missions as drinking water and as rocket fuel. Alright, so we're going to say goodbye to the moon now, and we're going to head off to the next planet, the planet Mars.